So in this video we will be seeing how to register our driver for any process creation or termination events. We can use this function ps set create process notify routine to register our driver whenever there is a process created or terminated. So this routine adds a driver separate callback routine to remove it or add it to the list of routines whenever the process is created or deleted. So callback means whenever an event occurs, the OS will try to call back our function saying that this process has been created. So we can consider this like real life example where you call your friend and says, if there is any courier came for me, you just call me back. So when the courier comes, your friend calls you back and tells that there is a courier arrived for you. So this is also similar. Whenever there is a process has been created, the OS will call our routine and says that hey, this process has been created. So the first parameter is the entry point of the caller supplied process creation callback routine. So we need to create a function and we need to pass the pointer to that function in this argument. And this function receives the values. So these are the values that this function is going to receive. So we need to pass a pointer of the function of the type that takes the parent ID as the first parameter and the process ID and the create, whether the process has been created or terminated. So this is the function we want to create and pass that pointer as the parameter. So this function is also defined in CentOS kernel. I have already declared the function signature. It's very easy. The function pointer is pointer and to remove u8. So first let's create a function that is a callback function. So public extern c function and process creation callback. So this function takes the parent ID and normal process ID and create or not. So it indicates whether the process was created true or deleted false. So is created u8 and this function should return nothing. So we have created the function successfully. Now we are going to call this function ps set create process notify routine, and the first parameter is the function pointer. So cast this as the pointer, and the second parameter is remove. So this tells us that this function callback should be removed or added to the list of routines in the OS. So we can say if false, the specified routine will be added to the list, so 0. Now whenever there is any process created in the system, our function gets called. So the process creation or deletion will be identified. This third parameter is created. So if is created is equals to 1, then that means new process has been created. Now we can do whatever we want. We have the parent ID and the process ID, and we are going to use one function called ps lookup process by ID. So here you can see ps lookup process by process ID. So this takes the process ID and it will return the pointer to the eProcess structure. So we'll be discussing that eProcess in the later videos as well. So pass in the PID and let mute eProcess is equals to. So this is of type U64. So we will get the pointer to the eProcess structure. So I have already set up this kernel debug. Now let's break into the VM, and now let me type process 00 and explorer.exe. I want the basic information about the explorer.exe process. And you can see this is the address of the eProcess structure. So you can pass this contents of the address as eProcess, and you can see lot of information. You can also see the pub base address. So what we are interested for now is the image file name. So image file name is an array of 15 characters. So and it is of the offset 588. So this offset changes from Windows versions. For Windows 11 it's 588, and for also some latest versions of Windows 10 it is also 588. From 1909 version onwards the offset changes. So we can see the structures of every Windows versions in a website called Vergilius project. So we'll be discussing that in the next video. So here image file name is of offset 588. So that means if I go and add 588, you can see the explorer.exe. So we are going to print out the contents at this address in our function, just to print that our callback has been received the process creation or terminated event. So we have the eProcess. So if eProcess not is equals to 0, then what we are going to do is we are going to, let's say, pname process name is equals to core pointer read. So I have also discovered that this core library contains this memory and pointer just like the standard library. So we can directly read from the address. So read the from eProcess plus 0x588. So we have seen the offset 0x588. Now we are going to read 15 bytes. Now we need to cast this as U8 array of 15 length. So declare like this. So this function will read the 15 bytes from this address. Now we have the array of bytes that we can go and print. So we can debug print process created and %s for the string format, and passing the address of this pname. So pname dot as mute pointer. So now we are good to go. Let's go and build this one. We can also do the same for process terminated as well. So we can just remove this if condition. So the process created or terminated, we are eventually enumerating the process name. Now we just need to print whether the process has been terminated or created. So if is created is equals to 1, then that means process created. Else we are going to say process terminated. We can also print the PID of the process to get much more information. So just pass the PID we have received. So process terminated. So I think we are good to go. So let's continue our VM. So let's run the debug view, and let's run our driver, and we can see a new process has been created. Let's go and create notepad. So we can see process created notepad.exe, and now let's close the notepad and we can see the process terminated. So that's all for this video. We can also see the output here. So that's all for this video. In this video we have seen how to register our driver for the process creation or termination callbacks. In the next video we will be seeing about how to hide our process from the user mode tools.